Everyone. Myself, Khaled Alkanad, research scholar at University of Mysore, Department of Physics, Department of Physics under the guidance of Professor Alkanad. My presentation entitled Synthesis, Structure, Characteristic, and Enhanced Dye Removal CO3O4 COO Nano Semiconductor Nanocomposite. First of all, we will introduce the importance of the work. The synthesis approach we follow, the characterization have been done to study the nanocomposite, the optical band gap of the composite, and the proposed mechanism of the dye removal. Here we see the industrial discharge, the toxic influence into the water reservoirs, so remain an important agricultural concern. In particular, textile dyes have a great impact in the flora and fauna at the scale that can adversely affect the biosphere, because these dyes reduce light penetration and prevent the photosynthesis of the sponge plants inside the water. Here we can see the drawback of the pristine catalyst, the rapid recombination of the electrons and hole, and in addition to the large band gap, which make absorb only the light with high wavelength number. To overcome these problems, several modifications have been proposed, like noble metal loading and metal ion doping, anion doping, composite semiconductor, and sensitization. The synthesis method we have followed is solution combustion method using carbon nitrate and glycine as precursor. These have been by optimizing the nitrate and fuel concentration and also calcination time duration. Moreover, here we see the characterization of the sample. The characterization of the sample we use here XRD result for the pristine nanoparticle, the nano and nanocomposite. The pristine nanoparticle showed high crystallinity, and in the other side, nanocomposite show Broughton's peak, indicating the composite formation, and low crystallinity in the sample. For pristine, it is high. Pristine sample is show high crystallinity, and the size of nanoparticle and nanocomposite have been formed. For nanoparticle, it showed around 16 nanoparticle, but for pristine, for nanocomposite, it show around 9 nanometer. Also here HRXPS result showed the composite formation, and also it showed low crystallinity of the composite. In the oxygen peaks indicate the presence of oxygen vacancies at 531 electron volt. The peak is indicating for oxygen vacancies on the surface of the composite. Moreover, the XPS results also reveal that the presence of carbon, certain amount of carbon in the composite. This due to less time calcination duration. Same images express the morphology of the sample. For the pristine catalyst C3O4, it has sponge-like morphology with higher crystallinity, high crystal size, and in other side the composite has foamy-like morphology with small crystal size. EDX result here also show the EDX. It conform the nanoparticle and nanocomposite formation. Also conforming for the nanocomposite, it has carbon. It has carbon also. And for DLS results, show the size of the prepared sample. For the pristine sample, size around 17 nanometer, 70 nanometer, and for the composite around 10 nanometer, which is will agreement with XRD result. Raman spectroscopy. The Raman spectrum of the samples for the single one, for the single crystal catalyst, all 5 Raman peaks have been appeared, and it show high crystallinity for the pristine sample. For the composite, broadened peaks have been appeared, and also this indicating the composite formation and also indicating the presence of oxygen vacancies, which will agreement with XBS result. UV spectroscopy was done to determine the band gap of the catalyst. For the pure one, it showed the band gap around 2.5. Band gap is little bit large. For the composite, it was 2.25 electron volt. The activity of the composite was studied for photo degradation of rhodamin B under sunlight. The composite show like 96% dye removal within 90 minutes, where the pristine sample showed only 45% within the same time. The photo degradation mechanism of the composite as shown here, it follow direct Z scheme charge transportation along with along with Finton reaction. The oxygen vacancies generate H2O2 with which activate the Finton reaction. Moreover, the oxygen vacancies accelerate the redox cycle of the cycle of the cobalt ions, exchanging the ion from CO plus 3 to CO plus 2 ions, which can react with H2O2 and generate OH radical. So here we can see also the electron react with oxygen vacancies and generating singlet oxygen. Here the mechanism approve of our proposed mechanism. We have studied the scavenger experiment to prove the mechanism and also the presence of H2O2. Isopropanol here IBA indicating that OH radical is the prime radical in the degradation, whereas the L-scobric acid LAA indicating also the superoxide radical also contribute in the degradation. Here also sodium azide, it is also scavenger of singlet oxygen, which show that singlet oxygen also have remarkable contribution in the dye removal. Moreover, also here for methanol and sulfur nitrate, methanol is a scavenger for hole, and sulfur nitrate also for electrons, which mean holes are contributed more than electrons for the photo degradation. Last scavenger is called trice. This scavenger is also a scavenger for hydroxy radical, which mean the presence of H2O2 generation, because recombination of hydroxy radical can generate H2O2, which indicate also the presence of H2O2. We conclude our work that our composite have been successfully synthesized by solution combustion method. The morphology show Bohr structure, which improve the photocatalytic activity. The characterizations conform also the formation of composite, and XBS Raman conform the existing oxygen vacancies. Also, we can see also the oxygen vacancies involved in the redox cycle from cobalt ion 3 to cobalt ion 2 to generate superoxide radical, singlet oxygen, and hydroxy radical. At the end, I can say thank you for your time.